So let's have a look at how to determine whether a turning point is a maximum or a minimum. Now, we've already had a look at this in terms of identifying it visually, and that's fine, especially with a parabola. You can do that. And I think as long as you state that it's a positive parabola, therefore the turning point is a minimum, or you could say it's a negative parabola, therefore the turning point is a maximum. And we can see that here. So here again was our parabola. Let's say a parabola looks like this. That's a negative parabola, and therefore the maximum point, the turning point rather, is going to be a maximum. Same with the negative parabola. Here's our negative parabola here. We can say, well, the turning point is down the bottom, therefore the turning point for a positive parabola is a minimum. So negative parabola, the turning point is a maximum. A positive parabola, the turning point is going to be a minimum. Now, we can also prove that one more way, which is probably quite a useful thing to know. And that is, all we need to do is, in order to find the gradient, we take the derivative. And then we take the second derivative to determine whether it's a maximum or minimum. Let me show you what I mean. So, we originally had this parabola here, and I'll just quickly draw this up. You will recall, I think it was, here it is, y is equal to x squared plus 4x plus 4. And then when we found the derivative of that, we want to say dy dx is equal to 2x plus 4. We're going to say, well, the turning point must be with a gradient of 0, so 0 is equal to 2x plus 4. And then all we have to do is make x the subject, subtract 4 from both sides, divide both sides by 2, and we're going to end up with an x is equal to negative 2. Notice I'm doing all of that in one go rather than talking it through, because you should know how to do that. All right, so here we go. Here's our turning point. I'll put negative 2. There it is. And the parabola is going to look something like this. It's going to go up here, and it's going to cross at this point here. And we know that this point here is going to be y is equal to 4. And we know that because if x is 0, because this is the x equals 0 line, the y-axis is the x equals 0 line. If I made this 0 and I made this 0, y is equal to what's left, which is 4. This is going to be the y-intercept. So now we can find out whether this turning point is positive, is a maximum, I should say, or a minimum. Now we know it's a minimum. It's the lowest point on the parabola, therefore it is a minimum. But we can tell by using the differentiation equation. So here is the equation itself. Here is the first derivative. Let's find the second derivative. Now the rule is this. If the second, if the second derivative is positive, then the turning point is a minimum. If the turning point, if the value of the second derivative is negative, then the turning point must be a maximum. So I'll write that out, yeah? So if the second derivative, and I'll actually write out second derivative here, d squared y over dx squared. That means the second derivative is negative, then the turning point is a maximum. If the second derivative, and I'll write it slightly differently this time, is positive, now notice to write positive, all I have to do is say is greater than 0. So this would be as less than 0. This is greater than 0, then the turning point is a minimum. All right, well, let's see how that plays out. Let's see if that's true. So I'll write out, so what, dy dx is equal to 2x plus 4. Let's find the second derivative, d squared y on dx squared. So I'm going to I'm going to multiply, the power, which is 1, by the coefficient, which is 2, And the x now becomes an x to the 0, which is a 1, and 2 times 1 is 2. And I've got my answer. There is the second derivative, and it's 2. So what do we know here? Is this number a positive or a negative? Well, we know that this number is a positive. We know that it's greater than 0. Then the turning point must be a minimum. So this is the proof using calculus that this is in fact a minimum. And you want to have something that says that, yeah? You want to say second derivative returns, why don't we just say it's greater than 0, yeah? It's probably a nicer way of saying it. Second derivative is greater than 0, therefore turning point is a minimum. And that's the statement we need to make in order to show we understand what this tells us about this parabola here. And that would be the way which I would go about that. Now here's the really important bit. This only works for parabolas. I mean, the second derivative works for everything. But if it's a parabola, all we need to do is find the second derivative. If it's something with a greater power than 2, in other words, it's going to be x to the 3 or x to the 4 or x to the 5 and so on, then it's not enough anymore just to throw in, just to find the second derivative. We have to use the point of the second derivative, which is this, and substitute that value in to the second derivative, and then ask the question, is it less than 0, or is the second derivative greater than 0? And the two things here will hold true. If you feed that value in, then to the second derivative, and I'll show you this in a second. I'll do exactly this in just a moment. So I'll show you that now.